Okay, hello grade 9, how are you? Hope you are all fine, miss you so much. Today I will complete the geometry curriculum with you, and our lesson today is called the relation between the chords of the circle and its center. From the name of the lesson, I want to know what is the relation between the chords. Chord of course means the line segment which pass through 2 points on the circle. AB is called a chord, CD is called a chord, and so on. If AB is a chord and CD is another chord, and I said it is relation between chords and the center, and I have circle M, what is the relation between them? If I have three cases, if AB chord is greater than CD chord, what did you see here, or what did you notice? You noted that the length between the center and the chord is shorter than the length between this center and the other chord. This means that if AB greater than CD, so MX, the distance, and when I say the distance, the perpendicular distance, not any distance, the distance between the center and this greater chord is shorter than the center and the shortest chord. So if AB greater than CD, so MX is smaller than MY. Okay, in the other example, if I have AB smaller than CD, you can notice here that the distance between the center and this shorter chord is greater than the distance between the center and the longest one. So if AB smaller than CD, so MX is greater than MY. What about if the two chords are equal? Excellent. So this means that the distance between the center and the two chords are also equal. Okay, so I can conclude here that the closer the chord is from the center, the longer the length of the chord. As we see in this example or that example, the closer the chord, this is closer to the center. So the closer the center is from the center, the longer the chord is. That's clear? Okay. Let's do this drill quickly, complete by using greater, smaller, or equal. We see here that MX here MX 5 centimeter, MY 3 centimeter. We said that the closer the chord is, the longest the chord will be. So here AB chord will be greater or smaller than CD. This is 5, so this will be the smaller one. So AB is smaller than CD. What about here? He told me that CD 7 centimeter and the chord AB 10 centimeter. So MX, he's asking about MX. MX will be smaller or greater than MY? Also smaller, because AB is the greatest chord. What about here? AB chord is 8 centimeter and CD chord is also 8. So the distance between the center and these two chords will be equal. Moving to another drill. In the opposite figure, MF smaller than ME. Where is MF? MF is smaller than ME. And I want to complete. Since MF smaller than ME, this is as it may come as a proof. Therefore, MF smaller than ME. Then which chord is the greater than the other? This is smaller, so this will be greater. So CD will be greater than the chord AB. Then he told me that CD equal X plus 1. So X plus 1 will be greater than what? X plus 1 will be greater than the other one. I will remove AB and write 7. So if I make it an equation, X plus 1, this is the length of CD, is greater than CD. I remove it, I wrote X plus 1. Greater than AB, AB equals 7 centimeter. Then X will be greater than 6. So X plus 1 greater than 7. So X greater than 6. Then he's asking, CD is a chord in center M. CD is a chord in center M. CD is smaller than what? CD also can be smaller than what? Who can think? It's greater than AB. But there is another chord which is greater than any other chord in the circle. Excellent. Of course, the diameter is the longest chord in any circle. And he gave me here the length of the radius. The radius is 5 centimeters, so the length of the diameter will be 10. So CD will be smaller than 10. So X will be CD as X plus 1 smaller than 10. So X will be smaller than 9. So here X is smaller than 9. Thus, X could be from what to what? I got that it's greater than 6 and at the same time smaller than 9. So it lies between 6 and 9. So X belongs to an interval between 6 and 9. So here X plus 1, X could be 6, 6.1, and so any other number till it reach 1. So it couldn't be 7, because if it is 7, if it is 6 exactly, that's why I make it open. If it is 6 exactly, it will be like the other chord, and which is wrong because he told me that ME is greater than MF. And if it is 10, it will be the diameter, and it is not the diameter because I have a length here between the diameter and the other chord. So this is a mistake, that this is not or equal. This is only smaller than, not smaller than or equal. That's why it is opened. Okay, this was an introduction about, again, if the closer the chord is from the center of the circle, the longer its length, and vice versa. Let's go to an important theorem. We have theorem corollary and the converse of the theorem. What does our theorem say in this lesson? It says if chords of a circle are equally length, as the example, the third one, then they are equidistant from the center. You remember this one? This one? If the two chords are equal in length, then they are at equidistant from the center. This is our theorem. Okay, very important to know if I have two equal chords that they will be equidistant from the center. Okay, what is the corollary? Not only in one circle and the two chords are equal and they will be equidistant from the circle. Equidistant, and I mean the perpendicular distance. Also, if I have congruent circles and he told me that the two chords, like these two chords AB, equal to CD, so they will be at equidistant from the center only. Okay, so in the opposite figure, the two circles M and N are congruent. AB equals CD, and at the same time, don't forget that I'm talking about the perpendicular distance, not any other distance, not the distance between M and if X is here, not the distance between M and if X is here, the perpendicular distance. If AB equals CD and MX perpendicular on AB, NY perpendicular on CD, then the two distances are equal. Okay, so they will be at equidistance. Okay, so I have two conditions. The two chords are equal and they are perpendicular on the chord, from the center to the chord. Okay, let's remember something very quickly that we took at the first lesson, that the straight line passing through the center to the midpoint, if I have a circle, okay, and I have a chord, and I draw a line passing through the center from the center to the midpoint of the chord, it's perpendicular on that chord. And another one was, corollary was, that if I have also the center and the chord and I draw a line which is perpendicular on the chord, it will bisect this chord. And if I have a circle and I draw a chord and draw a line which is perpendicular and bisect this chord, so you know that this line is passing through the center. This only to remember them. Let's see this drill. Study the figure and then complete. he told me here if AB equals to CD, so the two chords are equal. The two chords here are equal, AB equals to CD. Then complete MX, and as we see here, this is the perpendicular distance, and MY the perpendicular distance. Then MX will be what? Excellent, will be equal to MY. Since ME equal to what? Okay, equal to MY, it is equal to MO. That's what I have revised just now, that I have a chord and I have a line from the center perpendicular on this chord. It will bisect it. So ME equal to MO, then EX, this part, will be also equal to that part. YO. This is very important because it will come later on in the proof questions. Here if AB equals to CD, AB equal to CD, that means that CD and AB is 3x plus 4. Okay, he wrote the length here. Then ME equal to what? Excellent, equal to MO, because these are perpendicular. I want to get X. Anyone could tell me how to get X or to think? I told him that ME equal to MO, so X plus 2 will be equals 6. So X will be 6 minus 2 equals 4. So X equal 4 centimeter. Okay, I want the length of CD. CD is 3x plus 4. I got X from this one, 4. So 3 times 4, 12. 12 plus 4 equals 16. So the length of CD 16 and also the length of AB is 16. Let's complete the same. AB also equal to CD. Look here, he gave me that the two chords are not intersecting, nothing. They are far away from each other. In this one, they are intersecting, but nothing different. If they are AB equals to CD, then MX, this is the perpendicular distance, equal MY. In triangle MXY, if measure of angle M equals 100, so what will be the measure of angle MXY? This triangle. As we told him before that MX equal to MY, that means that this small triangle is an isosceles triangle. I have the vertex angle in the isosceles triangle, so I know that the two base angles are equal in measure. So each of these angles will be 180 minus 100 degree, the measure of the vertex angle divided by 2. So 180 minus 180 divided by 2 equals 40. So each of these angles equal 40. This one, M and N, are two congruent circles. AB as a chord equals CD, and as we see MX equal to NY, that means that they are equidistant from the center. That means that these are two equal. Then MX equal to NY, and what will be the name of the figure MXYN? Excellent, it will be a rectangle. This is an example to prove. Let's read it very well. AB and AC are two equal chords. Okay. In length in circle M, and X is the midpoint. When X is the midpoint of AB, what you will deduce here? Line from the center to midpoint of from the center to the midpoint of a chord. So this means that MX is perpendicular. This is very important. MX intersects circle D, the circle at D. MY, he told me in this case that MY directly it's perpendicular. It means that these two parts are equal also, and intersect the circle at point E. First, prove that XD equal to YE. We have just said it before in the complete, but this is as proof. I want to prove that this part equal to this part. Okay, first what I will say here, shall I give you a time to think? Okay, since x is the midpoint, so I must write this first. So mx will be perpendicular on AB, x midpoint, mx will be perpendicular. Since the two chords are equal and mx equal to my, mx perpendicular to AB and my perpendicular to AC, this is our lesson today, or our theorem. Two equal chords and the perpendicular distance here, this is perpendicular to this one, so mx will be equal to my. Okay, md is what? md is a radius, and also me is another radius, so the two radii in the same circle are equal. So md equal to me because they are two radii. If I subtracted mx from md, it will give me this part, and also if I subtracted my from me, it will give me this part. So as mx equal to my, so xd will be equal to ye. Sorry that I forgot to say this in this one. I forgot to tell you that why they are equal, because me are two radii in the circle, and these two are equal because they are perpendicular, and AB equal to CD. By subtraction, I'll find these two parts are equal also. Okay, let's complete. He wants me to prove that measure of angle, let's remove this one first, measure of angle YXB equal measure of angle XYC. I want to prove that these two are equal. Okay, from before I know that this is perpendicular and this is also perpendicular, so this is 90 degree, and mx equal to my, this means that the two smaller angles here from the isosceles triangle are equal because mx equal my, so measure angle y xm will be equal measure of angle xym. By adding these two angles together and these two angles together, the whole angle will be equal the other one. Is that clear? Drill, another drill here. In the opposite figure, triangle ABC is inscribed in circle M. Inscribed, we took it before that it is inside the three vertices touch the circle, so they are the triangle is inscribed. Okay, and measure angle B equal measure angle C. X is the midpoint of AB, my perpendicular on AC. I want to prove that mx equal to my. I think this is so easy. This is direct from our theorem and corollary. What do I need to prove that mx equal my? I want two things. I want first the two chords must be equal, and the two distances from the center to the chord must be perpendicular. If this happens, the two conditions happened, so mx will be equal to my. So first, do AB equal to AC? He didn't tell me in the given, but he told me another important given, that measure angle B equal measure angle C. So this will be an isosceles triangle, base angles are equal, so AB equals to AC. This is the first condition. The second one, he told me that my is perpendicular in AC, but he didn't say that mx perpendicular on AB. But he gave me another given that x is the midpoint. So as x is the midpoint of AB, and this line coming from the center, so this will be perpendicular. So since x is the midpoint, so mx perpendicular on AB. From 1 and 2, mx will be equal to my. The last part in our lesson today is the converse of the theorem. The theorem said that if I have two equal chords and I have the two perpendicular distance from the center, So these two distances are equal, or they are at equidistance, these two chords at equidistance from the center. In the same circle, or in congruent circles, chords which are equidistant from the center are equal in length. Chords which are chords with if my equal to mx, this means that, or you will deduce that the two chords are equal length, the opposite of the theorem. So here, if mx equal my, yd equals 7, then AB will be what? Of course, my perpendicular, so CD will be 14 centimeters, right? Because y will be midpoint of CD. As mx equal to my, so they are at equidistance, so AB will be equal to CD equals 14 centimeters. Okay, number 2, ME equals to MF, so the two chords also are equal, so CD will be equal to AB. Okay, and X, can I find X? Yes, I can, because 5x plus 1, which is the length of CD, equals the length of AB, which is 16. So 5x will be equal 16 minus 1 equals 15. By division, 5 will be equal 3. So x here equals 3. He needs the length of EM. We know that EM or ME equal to MF, and he told me that it's equal to 2x. So EM will be 3 times 2 equals 6 centimeter. What about AM? Can you get AM? Yes, this is a right angle triangle. Pythagoras theorem. ME is 6 centimeter and AB all is 16, and I know that this is the midpoint of AB, so AE will be 8. Applying Pythagoras theorem, AM square will be equal to AB square, which is 8 square 64, plus EM square 36, so equal 100. AM will be root 100 equals 10 centimeter. So AM equals 10. FMD equals to ME, then what? Then AB equals to AC. When AB equal to AC, this is an isosceles triangle. So measure angle B will be equal measure of angle C equals 65. So can you get measure angle A? Yes, 180 minus the sum of the other two angles, 65 plus 65, 180 minus 130, so angle A will be 50 degrees. Here MN parallel to BC, MN parallel to BC, MX equals what? MX equals MY. Okay, since the two circles M and N are what? They are congruent. Okay, because why they are congruent? Because MB equal to NC by this sign, so they are at the same radii, so they are congruent. A belongs to BC, then AB will be equal to what? Will be equal to CA or AC. Example here, two concentric circles. Concentric means they are having two circles having the same center. AB is a chord in the larger one and intersect the smaller circle at C and D. AE is another chord in the larger circle and intersect the smaller one at Z and L. Okay, measure angle ABE equal measure of angle AEB. And here I want to prove that CD equals to ZL. So I want to prove that the two chords in the smaller circle are equal in length. First, I have to draw mx as a construction equal perpendicular, to AB, and my perpendicular to AE. This is drawn by the book, okay, but it's not drawn in the question. So I draw first mx perpendicular to AB and my perpendicular to AE. If I talked about triangle ABC, the big one, the big triangle, okay, since measure angle ABE equal AEB, therefore what? Therefore the two chords are equal, AB equal AE, which are the two chords in the circle, okay? Therefore what? I draw mx equal to my perpendicular, then mx will be equal to my. This is the theorem, the first theorem. Two chords are equal, I have perpendicular distance, so it will be equal distance from the center, so mx, this part, will be equal to this one, okay? Then what if I remove the bigger one and I talked about the smaller circle? If I took the smaller circle here and I have a part which is CD and ZL, which I want to prove that they are equal length, and mx and my, we have just said that they are equal from the first part. I will use here the converse of the theorem. Since mx equal to my at equidistance from the center, so what? So CD will be equal to ZL. The last example here in our lesson, in the opposite figure, M and N are two intersecting circles. I want to remind you with something when the two circles are intersecting. If this one is N and this one is M, I call, if you remember, the line joining between the two centers of intersecting circles, or two centers of two circles, is called the line of centers. In the case of intersecting circles, this line of centers, and if I have the common chord here between the two circles, this line of center bisect the common chord and perpendicular on it. Very important to remember this. Okay? Okay, let's read our example. M and N, two intersecting circles at A and B. This is the common chord. MN intersect AB. MN intersect AB at point D. X is the midpoint of BC. When this is come from the center and X is the midpoint, it means that this is perpendicular. NY, where is NY? NY is perpendicular on EF. At the same time, MX and MD are equal. These two are equal. And ND, NY are also equal length. What did I want? I want to prove that BC equal EF. Oh, they are not in the same circle. How could I know? And they are not congruent circle, as we see. So how could I prove them why they are not in the same circle? So here I have to think to divide it into two parts, to divide or to talk about one of the two circles and then talk about the other. If I talked about circle M, let's see what are the givens in circle M. I have X is the midpoint, and I have MX equal to MD, and also I have AB as a common chord. Okay, let's think, what can I deduce from here? First, I can deduce that since MN, the line of centers, and AB is a common chord, then what? Then MD will be perpendicular on AB. Okay? And also MX, as X is the midpoint, MX perpendicular on BC. If you notice here well, that I have what? I have MX equal MD, the two lines here, and this is chord. CB is a chord, AB is another chord in the circle. In circle M, CB is a chord, AB is another chord. I have conditions. I have here MX equal to MD, and I have MX perpendicular to BC and MD perpendicular to AB. From this given, I will deduce what? I will deduce that CB equals AB. the two chords are equal, the converse of the theorem. Okay, this is number one. Let's move to the circle N. What I have in circle N, I have also that ND perpendicular, and I have ND equal to NY, okay, and also NY perpendicular to EF, this is a given. So, since ND perpendicular to AB, and AB is a chord in the circle, when NY perpendicular to EF, also EF is a chord in the circle, and they are at equidistance from the center, so what? So EF will be equal to AB also. From 1 and 2, I have here CB equal to AB, EF equal to AB, so CB will be equal to EF, which is the requirement. So here I have divided it into two parts. I talked about these two chords together by the converse of the theorem. Also, I removed circle M and I took these two chords in the bigger circle. Of course, I have exercise. This is the drills and the examples came in the lesson. Of course, I have 8 exercises, which is exercise 4.4. Please try to do it by yourself and ask me if you need any question in it. Also, you will find that I will upload the answer, but after 2 or 3 days, in order to let you think about them. I will upload the answer on your SMS, so please don't hesitate to ask me whenever you want, and please study well, listen to the video, and try to work hard and solve exercise 4.4. Thank you.